So let me get that started. Did anybody get that pop up that says, hey, yeah, okay. All right, so you just have to acknowledge that if you, um, does anybody object to recording? If so, then I'll have to rethink how I do this. No objections. Okay, good. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10 out of 13. So we're ready to go. My office that you see around me here is in my garage, and it has 4 windows in it, none of which have window coverings, and I don't have any air conditioning. So it's like sitting under a magnifying glass. I swear it's like 120 degrees in here right now. So I may not go the entire 2 hours. I hope you'll understand. Get my shirt back off. It's not as bad as it was yesterday, but I was up. My wife and I took a day trip because our car has air conditioning. You probably saw my email, and went out to the coast where it was only like 70 degrees, and then drove up and down 101 and 109 a little bit. Went through an interesting little town called Hump Tulips, which I've never heard of before. Apparently it means difficult pole, P-O-L-E. Well, it stands for, it's named after the Hump Tulips River, which natives, our indigenous natives named Hump Tulips, which means hard, difficult to pull, because it's difficult to pull your canoe through the river because of all the rocks and stuff in the river. So anyway. And then up to the, we didn't quite make it all the way up to the Hoh rainforest, which is also interesting. The H-O-H is the way it's spelled, which I always think is funny as a rainforest, because in chemistry, which is one of my hobbies, when you're making, when you're writing, molecular formula you're making or creating a formula, you often make water HOH, H2O. You often make it HOH because you got a positive hydrogen ion, then the OH, negative OH ion. So when you're going to split it apart, anyway. So rainforest, perfect for a rainforest, right? Water. Okay, so I just finished about an hour ago or so grading the one worksheet that is not automatically graded, or is partially automatically graded, and pretty impressive work. There were, I think, 4 perfect 10s. There were a couple that I couldn't give full credit on the manually grading stuff because of various reasons, and of course I usually didn't explain in great detail because you have 3 options to do it. And so you, just to let you know, you can still improve your score if you haven't done it 3 times already. So you're still free. That deadline, deadline of Sunday midnight, only applies to the first attempt. So you're certainly free to do it again if you haven't already done 3 attempts, and hopefully improve some scores if you wish. So I have not yet applied last week's attendance for the participation, so I still have that to do this evening sometime, and I will get that done. And then actually I could do tonight's as well, because we are, by the end of today, by the end of this message, we'll have yes, answer to your question, Eric. Yes, that means you can retake all the way up to the final, all the way up to the end date, which is set for August 15th. So yeah, you can retake the same with all of the worksheets that are, the worksheets, for the most part, a worksheet is a worksheet, right? Even if you get it wrong, I encourage you to keep going until you get perfect scores, because you're learning that way. And that's the whole purpose of the worksheet. So by redoing it, hopefully you're learning more. So that's what it's all about, is learning, right? Quizzes are a different story. You get the 2 shots and then that's it. And by the way, all quizzes are also the deadline only refers to the first time, and then you're free to retake the second one at any time. So a lot of people wait until the end of the course, and they're going, well, man, I'm at a B+ level and I really want to get those extra few points to get an A. You can go back and retake some of those quizzes and maybe improve them. And both the quizzes and the homeworks, excuse me, are highest score. So not an average score. All right. This week is interesting. So by the way, I think I've got this screen sharing thing fixed now. I was using the wrong link. I was using the link that I sent you, and that puts me on as a user rather than as the host, and that's why I had trouble last week. So I do have it set up now. So what I'm going to do is share my screen out here, and let's see if I can find the correct one. Yeah, let me open. Oh, I don't want it on that page. So go to the content page. All right, not join. Share. Okay. Can you see my screen? Yes, very good. So I'm on the content page, content tab right now. This video intro that you're looking at the top of this list in module 2 is not a new one. That's an old one that I left there from before. So I don't recall whether I made any comments in it specifically for that particular class from last quarter. But if I did, you can ignore that. Maybe if I get time, I can remake it, customize it. But it's, I mean, that one isn't that important. The idea is that I just wanted to introduce what this module is about. And this module is about 2 things: VLSM and wildcard masks. Now, VLSM. How many of you, maybe show your thumbs or something, the thumbs up thing there or something, had some VLSM in some of your courses in the past? Anybody? No? Okay. So VLSM, variable length subnet masking. What this does is allows you to make subnets between those octet levels. So in other words, rather than a /8/16, like that, /24/32, you can actually have a /27/28 or whatever, and you can subnet based on those inter-octet levels. So that sounds complicated. It's not all that complicated. And I'm not going to try to go into great detail here, but let me see if I can show you what I mean just a little bit. And I suspect that some of you will have had this, but you didn't know that it was called VLSM or something. It's called subnetting. So I'm going to go ahead on this spreadsheet here, and let's set my font a little higher so that everybody can see it well. And set this to center. If I'm looking at, and by the way, I don't know how many of you have already been exposed to the Z chart that I use for when I teach subnetting. It may have been in some of the videos that you saw in some of your other classes, like 179. Some of the other teachers also use those videos. So if I'm looking at the 4th octet, like that, 4th octet, I've got 3 rows, I should say, that I typically use. The first row is going to represent the number of hosts that you can get if you subnet to whatever, whatever number of bits that you borrow. It also represents the increment that you would that you would increment by each network in order to, well, let me put it this way. If little Mary had 256 beads in her necklace kit, right, and she wanted to make 2 necklaces, then she could get 128 beads per necklace, right, if she divided them evenly. So the increment would be 128, right? The first necklace would start with bead 0, and the second network would start with bead 128 if you were to number the beads. Does that make sense?
We can't see the page. It would probably help us better if we see the screen.
Sorry. Oh, you cannot see the screen? The Excel spreadsheet?
We just see the D2L right now.
Okay, only D2L. Okay, let me see if I can switch that somehow. Hold on here. Let me bring this back up. Oh, great. I lost my controls here. All I'm getting right now is just my screen with everybody's name on it. So, oh, there's, I see meeting controls. Ah, there we go. So let me see if I can switch that over to my Excel spreadsheet. There we go. How's that? All right. Thank you for letting me know. This is goofy the way it's not giving me the controls. All righty. For some reason, my Zoom is not giving me all of the the little boxes to make it smaller, minimize it, and all that. I don't know why. Okay, so hosts and increments is going to be my first row. The second row is where I put my subnet mask numbers, and the third row is going to be where I put CIDR notation, CIDR, classless interdomain routing. So in this first row, what I'm going to do is I'm going to just make the standardized set of bit values that you've seen probably 100 times before, right? If you haven't, you need to go back and review. But so the bit values that we're talking about, this is the 4th octet. So if I had 255.255.255. And then this represents that 4th octet. So if all these were full, if I had 1, 1, 1, 1, 1, 1, 1, 1 in the 4th octet, it would represent 128 plus 64 plus 32 plus 16. In other words, 255. Right? The subnet masks, if I were to borrow, let's say I had a number like 192.168.13. And I'm going to borrow 1 bit. All right. I would put a 1 in this location. So the subnet mask then would change to, if I were to say this one here is network, right? This is network, not host now. Normally it would represent a host number. But in this case, I'm going to borrow it and make it part of the network. So the subnet mask I would have to use would be 255, 255, 255, 128, right? So this represents the subnet. This is all going to come together, by the way, a little while. I know it's confusing the first time I do it. This is going to be 192 if I were to borrow 2 bits, 224. What I'm doing is I'm adding. I took 128, I added 64, and I got 192. I added 32 more, and I got 224. If I add 16 more, I get 240. 248, 252, 254, 255. Now, like I said, I know it first, This is confusing. Don't worry about it. I'm going to make it come together. The third is the CIDR notation. CIDR notation just means, or classless interdomain routing, is just another way to express the subnet mask, right? And in this case, the slash 20, this is a slash 25, and that refers to 25 ones. So 255.255.255.128. Well, 255 is 8 ones. Another 255 here. I put these all on one line, so I can't highlight just one individually very easily. So two of these, eight ones, another 8 ones is 16 ones, right? And then if I had another 8 ones here, that would be 24 ones, and then one more one makes that 25 ones. So slash 26 slash 27 slash 28 slash, oops, slash 29. I have to put the little single quote in here, otherwise Excel thinks it's something else. So 30, you would never have more than a slash 30, by the way. Slash 31 slash 32. Now I said that this up here represents the number of hosts you can get. If I borrowed this and made it a network bit, well, then I can't use it for hosts. So the most hosts I could get now is 64. But remember, when I use this number to represent the number of hosts that I can get, I always have to subtract 2, because the network is the first address and broadcast is the last address. I can't use those. So I can actually only get 62 hosts, 30 hosts, 14 hosts, and so on. So you just have to mentally subtract 2. Now, I said it would all come together. So let me make it come together now. Let's say that I have a network, and in this network, I have 4 subnets. I want to make 4 subnets. I'm going to begin with a number like 192.168.13.0. This is the network address of my original network. The subnet mask of my original network, and by the way, you don't know this is just something you're told, right? This is what you've been assigned, is 255.255.255.0. That's also a slash 24. Same thing. There are 8, 16, 24 ones in a row. All right, so that's slash 24. Now I need to divide this up in a way that I can get 4 subnets, right? Let's say I've got a management group, sales group, production group, and development group. And I need 4 networks so that I can divide these 4 up into different subnets. All right, so in order to do that, I'm going to have to borrow 2 bits, right? I have to borrow 2 bits because with 2 bits, I can get up to, well, I have to make these literal. With 2 bits, I can have the following combinations. Right, those are the only combinations I get out of 2 bits. Right? So I have to borrow 2 bits. This one and this one. All right. So that means that these are now network bits and the rest of these are hosts. So that means I can only get 32, actually 30 hosts per network, right? This is Mary's beads again, right? Instead of 256, she originally had 256 beads named 0 through 255. And she's going to take 2 of those sets of 8 beads away, right? So now she can only divide it up into, if you take 256 and divide it, divide it by 4, right? She can only get 32 beads per necklace. So let's make it happen in a way that we can see how this is used. And by the way, this is not VLSM, this is standard subnetting. So I'm going to make all the subnets the same size. All right, here we go. The management group, here, I'm going to just label these. I'm going to label this the network number. Oops, in network number. The network address. In other words, the first address in the network, which belongs to the network itself. It cannot be used as a host. It's the network number. Just like we said, this was the network number of our original network. The first usable address, the last usable address, the broadcast address, and then the subnet mask. So I need these four. All right, this is the network name over here. All right, so network number 1, network number 2, network number 3, network number 4. All right, 4 networks. The network addresses, well, the first network address is going to be what we've already know, right? We're going to begin our networks numbering with 192.168.13.0 for the first network. In order to get the second network, I need to know, well, what increment am I going to increment this by? Well, I said already that I can get 32 addresses in each network, right? And the reason I can do that is because, well, where am I working in this thing? I'm working in this column right here, the orange column. These two are now part of the network. So everything I do is going to relate to this column. So the increment is 32. So in the 4th octet, by the way, 4th octet, 32. So the increment 13.32. So that means I'm going to increment this 4th octet by 32. If the next network is going to begin with 32 more. 192.168.13.64. The next one's going to be 32 more. So these are my 4 network addresses. Cool? Because I just looked at this thing here and I said, hey, I know now that this is the increment that I need in order to make 4 networks of even numbers of networks. Now, this is all review, right? This is what you've done in the past in subnetting. Maybe not using my chart and this method, but this is what you've done in the past. I know that the first usable address is the next number above the network address. 192.168.13.1. 192.168.13.33. 192.168.13.65. 192.168.13.97. I know that the last usable host, well, I can't tell what the last usable host is yet until I get the broadcast address. How do I get the broadcast address? Just for kicks, what I'm going to do is I'm going to add 32 more of these things, right? And I'm going to say, well, what number, what's 32 more than 90? Oops, 32 more than 96. Well, that's what? Oops, I got something else coming up on my screen here. If I take, whoops, things keep popping up on my screen. Excuse me, 96 plus 32.
128.
128, right? Yeah, I just wanted to do it. I wanted to do it so everybody can see it done there. 96 plus 30. So everybody can see what I'm doing. So it's 128. 128. All right. In other words, if I were to make more networks, the next one would have been 128. I'm not going to use this, but except for anything except sort of bookkeeping to say, well, if this was the next network, then I know the last address on the previous network would be 127. 192.168.13.127. This is a 96, so the previous address to that would be 95. This one's a 64, so the previous address would be 63. And then this is a 32, so the previous address would be 31. 13.31. All right. Now I can get the last address because it's going to be one before the broadcast address. 192.168.13.30. 192.168.13.62. 192.168.13.94. 192.168.13.90. Oop, yeah, that one, 126. Got it. Now I have everything here except the subnet mask. Well, I've already chosen my subnet mask. I've said that everything here, and by the way, I see I jumped over one. I should have been using this one.
That's 198. The third one down is 192.168.19. It's supposed to be 13.
Oops, sorry. Let's fix that. Yeah, I made a mistake here. I jumped over. I borrowed 3 instead of 2. I should have borrowed just 2. I should have been using this one. I thought something was amiss there when I was able to get when I was able to get one more network out of that. I should have ended up with 256 there. All right. So so I guess we have actually possibly 8 networks instead of 4 networks. So I screwed up there when I started. The subnet mask, in this case, though, I'm going to continue where I left off saying I'm actually borrowing 3 instead of 2, is a /27 or a 224. Like that. And I'm going to use the same subnet mask for all of these. Right? Because these are all the same size network. Right? Now, this is standard subnetting. But the problem is, what happens if in, let's say, development, I only got 3 people on my development team? Well, I'm giving all these people 32, I'm giving 32 addresses away. And if I've got a large organization in particular, I want to use those addresses. Why am I, giving away my sales team? Yeah, I may have a whole bunch of people there, particularly my production team. That's probably my biggest team. All right. So let's say then let's call this out and do some VLSM. Do the same thing, but with VLSM, where I'm going to make different size networks for different groups of people. And that's what VLSM stands for, variable length subnet masking. So let's start with the production team. And actually, let me start in the same. I'm going to do it the same way. Management team, I've got, say, 10 people in management. So I need at least 10 addresses. My sales team, I have a pretty aggressive sales force. In fact, let's say I've got 15 salespeople. My production group, oh my goodness, my production group, I've got 100 people in my production. And my development team, I've only got 4 people in my development team. So the first step in VLSM, in order to make subnets for all of these people, is, and by the way, I should put these somewhere else other than my network number. I'm going to put this over here so that I can use this space. The first thing I want to do here is to put these in order of largest to smallest. And that's always the first step in VLSM. If you do anything else, you're going to mess yourself up. So we're always going to make largest to smallest. So I'm going to put my production team first. sales team second, management team third, and development team last. All right, so I've sorted them now, largest to smallest. Again, I'm going to number these. You don't have to number them, but I'm going to. And again, I'm going to begin. My very first network is going to start with my lowest address. Right, my lowest address in the set of networks that I've been given is 13.0. Now, I need 100 people in this. Yeah, that's fine. I need 100 people in this network. In other words, I need at least 100 addresses from first to last, right? Because I got 100 people in production. So how can I get 100 people? Well, in order to get 100 people, I can get them out if I borrow. Let's make these colors go away. If I borrow here, I need 100 hosts. Well, this, I can get 126 hosts here, 128 minus 2. I can only get 62 hosts here. So for my first network, I'm going to make that a 128. Okay, make sense? I need to get 100 hosts. Well, what's the increment for this first one? Well, it's 128. Increment's 128. So from here to the next network is 128. Like that. Because if I work backwards now, what's the broadcast address for this first one? Well, 192.168.13.127. Right. And the first address is going to be, first usable address, .1 and 192.168.13.126. So I can use for my hosts in this network, everything from 1 to 126. They're starting to come together now a little bit, now that I'm doing them. Good. Keanu's the only one that's visible. So I got to count on you, Keanu, to give me.
Yeah, it's making sense watching it now. Actually, this makes more sense than the first one.
This is starting to make more sense? Okay.
Yeah.
Yeah, I know a lot of people, once they start learning VLSM, they say, hey, this is actually easier than regular subnetting.
That's what I was thinking, yeah. Are you coming in the bedroom?
In a minute. Oh, I gotta focus.
So let me see. My sales group, I need 15 people. Well, I can't use this one because I can only get 14 addresses out of that. So I'm going to have to jump up to this one over here. So because 14 won't cut it for my salespeople. Besides that, sometimes you want to actually leave a little extra buffer anyway for growth. And in a real life situation, you would probably add 10 to 20%. However, for academic purposes, you usually, unless you're told otherwise, you just go with the smallest number that you can use. All right. So I need at least the 32 for this group. So what's the increment for, in order to use this column? Well, the increment is 32. So I'm going to take 128 plus 32, which gives me 3, 4, 5, 6, 160, right? +128 plus 32. Is that correct? Did I do that math right? Now I can work backwards here. Sometimes I do all these first, and then I work my way backwards. Sometimes I do them as I go. It just depends on me, right? On what I want to do. Or it depends on the moment. So let me see. I'll go ahead and do these as I go. 1 before 160 is 159. And I can fill these in if I want now. 192.168.13.158. And one higher than this one, 192.168.13.129. All right, so now I've got my first and last usable host addresses. This is actually the network address. This is the broadcast address. All right, for this group, the management group, I need 10 people. Well, I can fit those in over here. So I'm going to use this one for that group. Well, the increment is 16. So 16 above 160 is 176. The broadcast address for the previous one now, notice I'm always working one ahead, right? So I'm adding whatever increment I'm using. If I wanted to, by the way, I could do these, and I've done this sometimes in classes, and sometimes it helps people. Sometimes I predefine all these. And I say, oh, this is going to be a 128. This is going to be a 32. This one's going to be a 16. For 4, I can't use 4. I have to use 8. So that one's going to be an 8. All right, that sometimes is useful for some people to do that, but so 176, the one before that is 175. And now I can fill these in. 192.168.13.161 and 192.168.13.174. So these are the actual usable host addresses. Now, remember that I said, well, I make an accounting one here. I'm going to say, well, I need to know what the broadcast address is here, but I don't have a number here to make a broadcast address. So I'm going to go ahead and do one more just as sort of an accounting number so I know where this one ends. So I said my increment is 8 here. I need 4 hosts. I can't use this one because I can only get 2 hosts out of that. Remember earlier I said you'll never use more than 30? You'll never use a /31 or /32 because you can't get any hosts out of it. What would be the point? So I'm going to use an 8 for this one because I need at least 4 hosts and I can only get 2 hosts out of that. So that would be 8 more. So 176, 184, 192.168.13.184. Hope I did my math right. 192.168.13.183 would be the broadcast address then. This number here is just an accounting number. We aren't actually going to use it for anything. If we had more, we would. So 192.168.13.162 is the first address. 192.168.13.182 is the last address. Now I've got all my networks except, I have everything except the subnet masks. And I have to fill these things in. So for the first one, I use the 128. Subnet mask is 128 or /25, whichever way I want to do it. 255.255.255.128. Also known as /25. They are synonymous. This one, I use the 32, so it's a 224. 255.255.255.224, also known as /27. This one I used a 16, 255.255.255.240, also known as a /28. And then finally I used an 8, so that's this one, so it's a 248, also known as a /29. There we go. I've got my entire network all VLSM'd here. One interesting thing that happens though quite frequently is hopefully I can get my screen switched again. I don't understand what this thing's doing to cause this cause me not to be able to get to the meeting controls. Oh, there we go, up here. So I'm going to open up Packet Tracer, which is what you'll be using starting in week 4 in the class. Really cool simulator. And you won't be able to see it yet. until I get it switched over. It didn't actually start for some reason. Oh, there it is. It started. All right. Get my sharing going. Cisco Packet Tracer. There we go. You seeing my packet tracer screen? All right, good. So what I'm going to do is I'm going to just make a really quick network here. I'm going to put a router out here. I'm going to put 2 routers out here actually. And I'm going to cable here. I'm going to put 2 switches out. I'll take 2960 switch. And then let's put some PCs in here. So PCs. And I'll put some cables here. This is a cool simulator. You're going to love this thing. I'm doing it the cheating way, by the way. You won't be using this little lightning bolt for yours.
Will it work on a Mac too?
Yes, it will. There is a Mac version.
Awesome.
All right. How many networks do I have here? Somebody tell me. If you remember from 179.
2?
Close. 3. 3 networks. Yeah. I've got a network up here. This is remember everything, every port off of a router is a network, right? So I've got one network up here at the top from router 0 on up to that switch. So that's a network. And then I've got another network from router 1 down. And then I have another network in between routers. So this little network in here, how many addresses do I need? Well, I only need 2 addresses, right? It's a point-to-point link. So because I need 2 addresses, I would use a /30, which is 255, 255, 255, 252. So it's really common to see /30s, and that's because you have router-to-router links. Anytime you have a router-to-router link, you have a network, and you need those. So let me go back now to my spreadsheet. In reality, I would also have a router to router network that I would need in the case of the particular network that I just created. So in that case, I would need an increment of 4 because I can't go any lower than 4 because I can't get any addresses out of it. So I need 2 addresses. So I would use an increment of 4. And I'll call this point to point, right? And network number, this is actually a 5th network in this case. And then remember, I needed 8 up here. And so, in fact, I erased it. I should have probably just left it there. 184. 13.184. And then in this case, I'm using 4, so 188. This one now is my my sort of bookkeeping number, right? So I'm always going to take whatever increment I choose, and that's going to go in the next slot. That's the hard part for some people to remember, is where it goes. So now I know what the broadcast address is, 192.168.13.187. 192.168.13.185. 192.168.13. 1 less than 187 is 186. And the subnet mask for that one, that was a /4. So that was a 4. So that's a /30 or a 252. Anytime you see a 252 or a /30, you automatically know that's a point-to-point link. Well, not necessarily. I suppose I could have some weird case where I used it for 2 hosts, but that would be unusual. All right, so now I've got my entire network. Unless you're asked to, you wouldn't necessarily need to give me this line here in an academic exercise, but in the real world, you certainly do have to plan for those point-to-point links. All right, so now we've got an entire network. That's VLSM, variable length subnet masking. Cool, huh? It takes some practice. The subnetting series that I referred to in our, let's go back to our, there we go, that I referred to here in our notes. I gave you videos 29, 30, and 31, which are the ones about VLSM. However, if for some reason you need to review, or you want to learn the system that I'm using, what I just did, you can go back and review videos 1 through 28 if you want to. They're all less than 15 minutes long. I know there's a lot of videos, but it takes you baby steps. I mean, it starts with just counting in binary. So baby steps. All right, that's VLSM subnetting. Now, you have these videos here, and you have my notes on VLSM up here. Oops, go back. My notes on VLSM up here, and some videos within that, and then demonstration on how to do it. And this is exactly what I just did. So practice, 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 right? The other thing we're going to cover this week is wildcard masks. Wildcard masks you will use later on in the course. So this is going to seem a little, like, why am I doing this at first? But when we get into OSPF and then into access control lists, we don't use subnet masks. We use wildcard masks. A wildcard mask is the inverse of a subnet mask. And why would I do that? Why wouldn't Cisco just set it up so that we use subnet masks? Well, the reason is that wildcard masks are, whereas subnet masks have to be contiguous 1s and contiguous 0s, wildcard masks don't have to be. So you can get really creative. Now, we're not going to get to that level. I'm not going to make you do discontiguous, although I gave you some examples of it. Like here's one where I have all zeros and then 1, 0, 0, 1, 1, 1, 1, 1, 1. But you can do crazy things like every odd numbered network is, every odd numbered host address is on one network, and every even numbered one is on another network. Right? You can do things like that rather than having chunks of addresses. So these are used whenever you want to filter something. I want to say, well, all of these addresses don't pass a firewall, right? Where all of these addresses do. So we use wildcard masks just because they're more flexible in our ability to define a number of addresses that pass or don't pass. So they're always the inverse of it. And when I say the inverse, what I'm referring to, again, I want to switch screens here. I'm going to go ahead and break this out. 255 into different cells. 255 dot, let's say I have 128.0. Okay, this is a subnet mask, 255.255.128.0. If I subtract 255 from each of these, I will get the wildcard mask. 0.0.127.255. Now the trick is how many addresses does that number represent? Well, in order to explain that, let me take a simpler case of 0.0.0.7. Okay. By the way, you notice that this is always going to come out to one less than what these numbers are up here, these host numbers. It's just the way it works, because if you subtract from 255, it's always going to be that odd number. So if I had 255.255.255.248, that's this case, 255.255.255.248. Oops, those are not dots, are they? There. And I subtract, I take 255, 255, 255, 255, and I subtract it out, I'll come out with 0.0.0.7. So that's how you derive a wildcard mask, is just take 255, 255, 255, 255, subtract out the subnet mask, and you get the wildcard mask. And this actually turns out that it represents 7 addresses. Right? So how that works, yeah, a little bit tougher to explain how it works. And there's no reason to muddy your minds with how it works. I could explain it, but I don't think I need to, other than to say that's going to represent 7 addresses. Now, the reason I told you about this is you're going to be doing a, let me switch this over again to our course. Get it to our course here. You're going to be doing a worksheet, and I want to help you get started on the worksheet on how to think about these things. So wildcard mask worksheet, that would be down here in the labs and assignments. Wildcard mask. I'm going to give you some challenges in this thing. All right, can you see the worksheet okay right now? No, okay. I have to switch this sharing thing over so that you can see it. How about now? All right, so there's the worksheet. And move this thing out of the way and enable editing. There we go. So here we go. Let's talk about the different kinds of problems that you're going to find in this thing. The entire 192.168.1.0/24 network. Well, how I gave you this one. If I want this entire network, well, I see that the subnet mask is /24, right? /24 is 255.255.255.0. So if I subtract this out from 255, 255, 255.0, or 255, 255, 255.0, I get 0.0.0.255. That is the wildcard mask to represent this entire network. If this were a access control list, I would say that in this case, all of these things do not pass. They're not allowed on my network, but anything in this last octet is allowed on my network. So in other words, anything that starts with 192.168.1 is allowed on my network, right? Or allowed to cross my network, or whatever it is my access rule is allowing, or a firewall, right? Everything on this network would be allowed on the firewall, and everything else in the 192.168.5, right, would not be allowed on my across my firewall. So let's take we have entire network questions, and this was one of them. Here's another one. So somebody help me out here. What would be the entire 172.16.0.0/8 network?
0.255.255.255.
Yeah, because there are 8 bits, right? 8 ones. So 255.0.0.0 would be the subnet mask, right? And so in order to switch that, make that a wildcard mask, I would have to switch it 0.255.255.255. All right, let's try one that is a single address. That would be the second type of problem here. How would I specify a single address?
Subtract each octet by or from 255.
Yeah, so if I had, if in a subnet mask, in order to make a single address, you have 255.255.255.255. So in this case, it would be 0.0.0.0.0 would represent a single address. This one's real simple, just a subnet mask, right? You just subtract it from 255, 255, 255, 255. Now I want 16 addresses. I want to represent this just 16 addresses. How can, now, by the way, whenever we talk about a specific number of addresses, you can't get numbers, you can't start with numbers between them. I don't know if that makes sense. Like, in other words, I would have to have a network that is like a .0 or a .16 or a .32, right? I can't start with a .5 and say, well, I can get 16 addresses from there and filter them with a wildcard mask. So I would have to make a larger network in that case. I'd have to say, well, I'm going to allow, say, 32 addresses or something. But, and by the way, I misspoke earlier. I said, let me get back here to my spreadsheet. There's my spreadsheet. I said this represented 7. It actually represents 8 addresses, not 7 addresses, because I forgot to include 0. Right? So that actually represents 8 addresses. So I can use any of these numbers minus 1, right? So if I said, if I made this a 15, this will filter out exactly 16 addresses. All right, so 0.0.0.15 would represent 16 addresses. Get back to my share here. There we go. So 16 addresses. So that's the third type of question here. You got entire network, a single address, a certain number of addresses that you want to be able to pass. Now, how these are, what I mean by pass or, to filter, don't worry about that yet. We'll get to those when we get to ACLs and to OSPF. You just know that this represents some set of addresses, right? That's all you have to worry about as far as what wildcard masks mean, and how we apply that we'll talk about later. Here's another case of a single host. Here's another case of a single network.
Can't see your worksheet.
Oh, you can't see it? Sorry. This thing, I thought that I had it. Screen, wildcard mask worksheet. Can you see it now? No?
Not yet.
Not yet.
How about that? No?
No, not yet.
It's not switching over. Let's try this. That work?
Not yet.
Oh, so I have a little thing here that says your screen sharing is paused. See if I can figure out how to turn that off and get back to this. How's that? No, oh, no, it still says paused.
Oh, I can see it.
Oh, you can see it?
Yep.
Huh. Oh, now it says you are screen sharing. All right, now you can see it. All right, so let me go over that again. So you have an entire network, a single address, an entire network, or well, network mask, a certain number, one host. Here's another entire network. This, I see I made a typo, and I can't change it because I've got this thing locked. I'll have to get my password in there. There we go. Associate wildcard mask associated with 152 115 128 0/17. So again, that's I'm looking at a particular subnet, right? Wildcard mask associated with this address. So you'd have to look at /17, figure out what subnet mask /17 belongs to, do the subtraction, and you get the wildcard mask. How about this one? Every IP address.
I mean, all zeros, right?
Well, all zeros is a single address. Because remember, a subnet mask for a single address is 255, 255, 255, 255. So 0.0.0.0 is a single address. So it'd just be all 255s, right? For example, and I know we haven't really looked at routers yet, but if I want to make a default gateway for a router, and I want to say, well, every address that you don't know about goes to some particular other router, I just make it. I say, well, the address 0.0.0.0 with a subnet mask of 0.0.0.0 goes out of port 5. So 0.0.0.0 in a subnet mask represents every address. So for a wildcard mask, every address would be represented by 255.255.255.255. Now this one's tricky. What about this one? The classful address in the 172.30.0.0 network. A classful address. What are we going to do with that? Ideas?
Isn't that the first octet?
Yeah, you'd have to say, well, what class is a 172 address, right? 172 is a class B address. So now you need to know what the standard, what the default subnet mask is for a class B address and work from there. I'm not going to help you too much. I'm not going to tell you. So you have to figure that out. Here again, you've got a subnet, a single subnet, which we did up here. Same thing as, say, this one, a single subnet. So what subnet does this represent? And by the way, notice it's a /30, so it's a point-to-point link. But and then do that translation. The last 8 addresses. So I want the last 8 addresses. Okay. This one's a little bit tricky, because when I said last 8 addresses, well, I don't care which 8 addresses I'm using. If I'm just specifying the wildcard mask, well, which addresses I'm using is determined by the network address that I give you. So that determines the starting place, and then the wildcard mask that you use determines how many addresses from that point. Entire network. Here's another entire network. However, this one I tricked you. I said the entire network in which this address exists. Well, what network is that? How do you figure that out? I'll work through that part of an example with you in a moment, so that you can figure out how to do the rest of the question. Again, first 4 usable addresses. Well, we don't really care when we're doing wildcard mask. We don't really care, well, which 4. We just want to know, well, how would I make 4 addresses? Well, that one's kind of tricky, because remember, I can't make just 4 addresses. I can make 8 addresses. Well, no, actually, I can make 4 addresses, right? I can do 4s. I can do 1s, 2s, 4s, 8s, 16s, right? So you'd have to figure out, and again, I'm not going to tell you, but what wildcard mask would give you 4 addresses. By the way, when you're doing wildcard mask, don't worry about the network address and the broadcast address. Don't say, well, 4, well, I can't get 4. I'd have to jump to the next one, to the 8s. You don't have to do that because we're not dealing
So-
with the network address. Yeah, go ahead.
What does the usable mean then? Because that's what I was thinking when I first read that. The first 4 usable, I was like, okay, so that's minus those 2 other, the broadcast and whatever host.
Yeah, because that's to throw you off, right? So you don't really care. All I care about is how many addresses I can get out of a wildcard mask. Because in this particular case, if you did jump to the 8 and give me a .7 there, then I wouldn't take any points off of that because it would imply that, yeah, I'm going to need more addresses than 4. But typically in a wildcard mask situation, you don't worry about whether they're usable or not. So that's just to throw you off. But again, I wouldn't take off if you jumped up to the next one. All hosts, well, again, that's the same as in the entire network. And both of these are all hosts. So you just look at, well, what network is that? So play around with it. Remember, again, this is a worksheet, not a quiz. So you get, if you do it and I grade it and, you get it wrong, try it again. Keep going till you get it right. And I'll give you some hints as I grade it. Unfortunately, I don't get to grading until usually on Mondays. So I noticed some of you did like 3 attempts all at once before you got it back on the last worksheet. That's okay. You can do that. But this one will not be self-grading. I have to grade it. So you probably, after the first attempt, unless an epiphany comes and you want to turn in a second one, then you probably want to wait until I grade it to see what, maybe I'll get a chance to grade it midweek as well, to give you another shot at it this week if you want. All right, so I know these are tricky. They're the first time you've ever done them, but give it your best shot. If you don't quite understand it yet, you're in good company. A lot of others won't either. All right, let's go back up to the content here. Notes and resources. So I've got my notes on VLSM, my notes on wildcard mask, the videos on VLSM, the standard subnetting videos if you care to review that. Optionally down here, these are just, if you want to use these are excellent.
Hey, Prof, we're stuck on the Word document again.
I'm sorry, you can't see my screen. I keep forgetting that I have to switch that over. And I really don't understand how this thing is doing this because I have to stop the share to get this thing back to where it needs to be. There we go. How's that? Better? Can you see
Better.
it? All right. So optional. Down here you got optional things. So these videos, of course, are optional. This is 1 through 28. In case you've forgotten how to do standard subnetting, you want to review that before you go on to VLSM. It's a lot of work if you have to do that, but it's there for you. This is a workbook that is out all over the internet and easy to find, but I've given you both the workbook and the instructor's edition to the workbook. And you can work your way through this if you want to, just to practice and learn addressing and subnetting and addressing. And then here's one on VLSM, specifically on VLSM. So feel free to go through the workbook and work some of the examples. Then you can check yourself by using the instructor's edition. So again, those are optional, but if you want to review or you want to, or my method of showing you VLSM isn't working, you can sometimes use somebody else's method. Sometimes it makes more sense. There's so many ways to teach subnetting. And mine's best. I I say that for one good reason. My master's thesis was on how to teach subnetting. So it's in education. It's in course design, instructional design. So and in one session sitting here right now, it's hard to show you the entire series, entire system, but I did it in a two-day boot camp version for my master's thesis. And I had 20 people who did this 2-day boot camp, 2 8-hour days. And they absolutely failed the test when they came in, even though some of them were working professionally in the field. And my average score was 87, something like 87% by the end of the second day for very, very complex problems. So I can teach it in 2 days, in 2 8-hour days easily. Where most people it takes 6 months. So I can't do it in an hour very easily, but hopefully what I just did helps some. And hopefully my videos will help even more. And then finally, of course, we've got the 2 worksheets. This time they are not automated. They are the Word documents. You'll fill in those blanks like we were just looking at, and then I'll grade them. And like I said, I'll try to midweek to get through one round of grading, and that way it gives you another shot this week to get some of the others out of your way if you want to redo it. And then finally the quiz, which is over VLSM and wildcard math. So you can imagine this is a quiz, one of those quizzes that you might want to it's likely to have math in it, right? You're likely to get some questions about what's the third network in this case like this, and I give you some case or something of that nature. What's the third network address, or what's the first network address in such and such. By the way, the subnetting practice, I know you can't see my screen right now. I'm on my browser, and I'll switch it over in a minute, but I got to find this web page.
We can see it.
Oh, you can see it?
Yes.
Cool. Okay, so subnettingpractice.com, I believe, is the one I'm thinking of. Subnetting questions. What is the / notation for this subnet mask? And you can try to answer it, and then you can show the answer, right? Hit next, and it's just going to give you one after another after another. Here's a point-to-point link. Given the following point-to-point /30 link, what is the IP address of the unknown router? So you've got, in this case, you're using a /30, so you've got 4 addresses, 2 of which are usable. And if this is if this is a .10, what's the missing IP address in that one? Well, you have to kind of figure out where you are, right? Where those addresses are. Oh, by the way, I said I would go through one case in the worksheet and show you how to do that. So let me switch over again. I'm going to do a stop share and then a start share. I'm going to switch over to my spreadsheet. And this question that we just saw there is a case like this. So let's say that I'm given a question. Can you see my spreadsheet right now? Yes, okay. Let's say that I give you a question, something like this. What is the last usable address in the network on which host 192.168.42 let me see here, 63/28. exists. Now you had a question in the wildcard mask that said, you know, this on the subnet in which this host exists or something like that. Well, how am I going to tackle this problem? Well, I'm going to look at the I have a double slash there. I'm going to look at the increment. There it is. Fix that. I'm going to look at the increment that a /28 represents. So a /28 represents an increment of 16, right? So I know that my addresses are going to be .0, .16, .32, 64, 80. Okay, that's all I need here to figure this out. So if these are my network addresses, right? These are, remember, my increments for a /28 are 16. So these are all my network addresses. I forget the zero. The zero is being filled in by Excel because it looks like a number. Okay, so this is 192.168.42.16, 192.168.42.32, and so on. I should have made these text instead of numbers. So if I'm looking down this thing and I want to know where 63 is, well, 63 is going to occur in. Actually, I kind of gave you a bad situation because that is not a host. that's actually if you were given this question, that actually is a broadcast address, right? Because .64 is a network address. So the broadcast address is a .63. So when I made that up, I gave you a bad example, but the answer would be none of the above or whatever in a multiple choice, because that's not a host. That's not a valid host address. And if you were to put this in and try to make it a host address on your PC, it would yell at you and not allow you to do it because it says, that's a broadcast address. So in order to fix that, let me make this, instead of 63, I'll call it 60 there. Oops. Now it's a valid question. All right. So this is 0 to 15. This is 16 to 31. This is 32 to 63. Right. This is the broadcast addresses over here. This is 80 to 80 to 79. So I can go, well, wait a minute, 60 occurs in this. This is the third network. Well, the question I asked is, well, what's the last usable address? Well, the last usable address is one before the broadcast address. So the answer to this question is 192.168.42.62. Right? Make sense? So all I did was I said, well, what's this subnet mask? And the subnet mask was a /28. And so therefore I know that my increment is 16. So I know now what my network addresses are, what my broadcast addresses are, and I can derive the first and last host addresses. So that table I gave you earlier where I worked through, network address, first address, last address, broadcast address, you'll find that as you use it more and more, you'll just stop making this whole table and you'll start just looking at the network addresses and then deriving it, whatever piece of information you need from that set of network addresses, from that set of increments. The first time I ever took the CCNA test for Cisco, I was just barely catching on to this stuff. I mean, I was using the same method, but I was actually making an entire table. So I took for every one of these increments up here, I actually they give you a laminated sheet of paper and a dry erase pen. You get one laminated sheet and a dry erase pen for the whole test. And I filled one side of this laminated sheet with 32, 64, 96. And I made all these long lists of increments so no matter what subnet mask they gave me, I could quickly look it up. But and I asked him, how much time do I have before the test that I can write down stuff on my laminated sheet before before it starts counting my time? I said, no, take as much time as you want. So I did. I took about 10 minutes writing all these long lists of increments down so I could look things up quickly. And then when I started the test, it said, oh, by the way, your time for the practice questions at the beginning of the test is expired. So I didn't, where it tells you what the questions are going to look like and how to go about tackling them. So I missed all that. But I don't do that anymore. As long as I've got this little chart here, now I don't worry about it. I just start, I just make my increments real quickly as I need them. And then I can derive all this other stuff from the broadcast first, last, and so on from that, as well as the subnet mask. So you get used to it. It just takes time and practice. So anyway, that subnetting practice thing, you probably can't see. New share, subnetting practice. Get back to it here. There we go. Can you see it? No? Oh, now you gave me a thumbs up now that I told to stop. Thanks. Get back to it. There, the subnetting practice sheet here is really handy. I mean, you get all sorts of different questions. There's another couple of you can start getting used to these things. A couple of pages that do similar things. Let me go back here. Subnetting. Subnetting practice. No, that's not the one I want, although that one's pretty cool as well. Oh, they may have taken the other one away. Nope, I think this is it. Subnetting.net. Yeah, this is the other one. Subnetting.net, subnet /subnetting. This one doesn't give you all those diagrams and stuff to confuse you. So this one might be even better. So enter the subnet host. The subnet, the host 172.18.243.222 belongs to, and that's the same kind of problem I just now worked for you. So it gives you a host number and a subnet mask, and you have to figure out, well, what's the network address for that host. So these are really handy, and man, you do enough of these, you just do 2 or 3 of these things a day, you'll get real good at subnetting after a while. All right. Do we have any questions, any problems, anything anybody wants to talk about? I'm going to stop the share here. I see lots of things over here. Yeah, okay. I wasn't able to see these chat things as I was going because I was on the other screen. So I apologize for that. But anyway, all right. Any questions, any problems, anything that I know some of you are probably confused right now. If you don't do subnetting a lot, it takes some time to catch on. If you are struggling, I highly, highly, highly encourage you to watch that set of videos. I know that 31 videos is a lot of videos, but it'll take you very, very small step by step. And I have had, at another school, I also teach at Clark College, and they actually have a course in subnetting. And I've taught that course, and of course we're all using the same curriculum. So I got the same curriculum somebody else is teaching from, and I have my own way of teaching. So I teach both methods concurrently, and I've had more students come back and tell me that they said, man, after I watched that video set, I do these things in my head now, and I used to get fail this other course. So. No questions. No comments.
There's a question on the
Yeah, I
chat.
have one.
What's that? Oh, do we change our networks to internal from NAT? Are you referring to like VirtualBox or something? I'm not.
Yes. Yeah. Because I've done this before. I've created them before, and we had to change them to internal to get them to communicate. And I didn't see that in the instructions, so unless I missed it.
No, you shouldn't. Actually, we don't necessarily need to use virtualization for this. We're just going to be doing it on Packet Tracer once we get into, networking, once we get into creating networks. So no, there won't be any.
So change it back to NAT.
Well, I don't even know actually what you're using VirtualBox for at this point.
TCO1, 2, and or wait a minute.
Are you looking at a different class?
Never mind. I'm sorry, dude. Yeah, I'm taking so many freaking classes. Yeah.
Yeah. Okay. You're looking at one of the server classes or something, or
yeah. Network. Yeah. Sorry.
Okay, no problem.
Which it lines up, but hey.
I teach those too. So
yeah.
I'm working on. I'm on the. Oh, you're gonna hate me. No, I'm working on a revamp of 4 of our server classes right now, and my particular role on that team is to write all the questions for all the quizzes and tests. So
you can get the administrator, not the administrator.
Those who have had me,
scheduling.
those who have had me before know that I tend to write tough questions on some classes. So
it's the 3rd time I've had you.
My questions aren't always easy, are they?
No, but you're the only person that gets on there and explains everything. And
Okay.
it doesn't show me a post from 1982, saying that they posted in 1982 the last time. So yeah, I'm good.
Yeah, I'm glad that they're helpful, and sometimes I get rushed and I don't explain things as much as I'd like to. So, by all means, let me know if that if I can help with anything. And I make a lot of mistakes in D2L, and the reason is because D2L is so stinking complex to use on the teacher side of things. More reading, more practice. Yep, absolutely. Anything else? Any other questions, comments? Nope. Okay. Probably all want to get out of here by now. This has been long. All right. I'll leave you to it though. Then, and by all means, feel free to write to me, ask me for help. Also, I highly encourage. We always have a few who just get subnetting like nobody's business. I had 140M class one time. I had a student who was had a pretty severe learning disorder, and it was pretty cool to watch because while she struggled with everything else, man, she got to subnetting. She was doing it like a pro in 2 days. Just sometimes it's just a mindset of getting past that it's math, and then it just comes easier. So, what was the website to practice? Good question. So my favorite one is actually subnetting.net. What I do is I just Google subnetting practice, and there's subnettingpractice.com comes up, and subnetting.net comes up. Subnetting.net does not give you all of the network diagrams, whereas subnettingpractice.com does tend to give you network diagrams. And so sometimes until you've had some experience with those diagrams, the subnetting.net is easier because it's just, what's the first address on this network, or what's the last usable address on the network on which this host exists, and things like that. So that one I find is a little bit better. Let me put those links here. Hold on. I'll put those 2 links in the chat. I have to switch back and forth here. So this is the subnetting.net one. And then the other one is just subnettingpractice.com. The second one here is the one that has the diagrams. So the subnetting.net one is probably a better one for where we are in our studies. Okay, anything else? No? All right, let's end it here then, unless there is. So thank you so much, guys. And I will stop the recording now, and I will post it once I get it uploaded. It takes about 10-15 minutes to get it all uploaded, and I'll post it in the notes.